All right, I want to talk about a geometric sequence here. We've discussed arithmetic sequences. Arithmetic sequences are sequences where you add to get the next term. When a geometric sequence, you're going to multiply to get the next term. And what do we multiply by? Well, we multiply by the common ratio. And if you're ever unsure how to find it, just remember the common ratio will be, let's say it'll be the third term divided by the second term, or the second term divided by the first term, or whatever the case may be. Oh, first term, okay? So you call this term the common ratio, or R. When we multiply to get the next term, R is greater than 1. When you divide to get the next term, R is less than 1. What I mean by that is, for example, if R equals 1/2, you're taking half of the number. You're basically dividing by 2 as you go. So keep that in mind, okay? So the two formulas we're going to use, again, as we did with arithmetic, are the explicit formula and the recursive formula. So the recursive formula helps you find the next term. I will tell you what the first term is, or you will identify what the first term is, and then you'll get the current term by multiplying the ratio by the previous term. Or you could say the next term multiplying by the current, whatever it may be. So I'll give you the first term. Hopefully you'll be able to identify the common ratio. A sub n is the previous, or the current, sorry, a sub n minus 1 is the previous. The explicit formula helps you find any term. So I'll tell you, the term I need is the first term times the ratio raised to the n minus 1 power. A sub n is the nth term, a sub 1 is the first term, R is the common ratio, n represents the nth place, whatever that may be. So both of these are really nice because if you know one term, all you're going to do is multiply to get the next term in a recursive formula. In an explicit formula, you can find any term. So the 100th term I can find right away from here. Over here, if I needed to find the 100th term, I would have to know the 99th term. But in order to know the 99th term, I have to know the 98th term, which builds on the 97th term, which builds on the 96th, the 95th, the 94th, and so on. So those are the advantages and disadvantages of both. All right, so let's look at our first example here. For my first example, I've got the sequence 4, -12, 36, -108. Okay, so what I need to know is, okay, so they've got blanks. They need me to fill in the next terms. Well, how did I get to those two terms is my question. Well, how does 4 become -12? That makes -12 become 36, that makes 36 become -108. Well, here it looks like we multiply by -3, because 4 times -3 is -12. How does -12 become 36? Well, again, we multiply by -3. And I bet if we multiply by -3, we would find that 36 equals -108. So that appears to be our step. That's how we get from one term to the next. So to find the next term, I will take -108 times -3, and that gives me 324. And I'm going to multiply by -3 again, and that will give me my next term, which is -972. So find the next two terms. Yeah, we did that. All we did was follow the pattern. What is the common ratio? In other words, by what number did we multiply to get that? Well, we multiplied by -3. Now I want the recursive formula. The recursive formula, I know that my first term is 4, and I get my next term by multiplying -3 times my previous. The explicit formula, remember, it relies on you knowing the first term and the common ratio. Oh, that's a -3. Let's clean that up a little bit. So my first term is 4, my ratio is -3, and I raise that to the n minus 1 power. One thing I want to point out here is I've got a subscript. Subscript represents the position. Superscript represents the exponent. So you're doing math here. You're ordering or placing here when it's in a subscript. So now let's write the function for the sequence by rewriting the explicit formula in simplest term. And you're thinking, it's already simple. What else can I do? Well, actually, there's a good bit. So we're going to rely on 8th grade math where you learned about negative exponents. And the first thing I'm going to do here is I'm going to expand this value. So this is really negative 3 to the n times negative 3 to the negative 1. And so this part right here, remember with your negative exponent, that's where you turn this into a fraction. So it's actually going to be 4 times negative 3 to the n power times 1/3. And so my final answer will be negative 4/3 times negative 3 to the n. And yeah, I had to walk you through that, but what I need you, what I need you to keep in mind is that sometimes you're going to see it this way on an assignment where it doesn't follow the recursive formula or the explicit formula. It just gives this to you as a function. So I just want you to see that you can write a function in the same manner. All right, so now that you've written an equation given a sequence, I want you to give me a sequence given the equation. So I've got a recursive form of an equation, an explicit form of an equation, and a function form of an equation. So let's go through these. So here my first term is 4. I'll define my second term as negative 5 times my first term. And so I'll get negative 20. My third term will be negative 5 times my second term. So negative 5 times negative 20 is 100. Do you have to write in this step? Oh no, I'm only showing this to you for teaching purposes, but in most cases, I would skip this step. Now for the explicit formula. To find my first term, I'm going to take 7 times 1/3 to the 1 minus 1. Well, that's 7 times 1/3 to the 0, which is 7 times 1/3, or, so, whoa there, Denise, what are you doing? My bad. What's 1/3 to the 0 power? 1. And then 7 times 1 is 7. Oh, forgive me, please, for that mistake. Okay, my second term will be 7 times 1/3 to the 2 minus 1. That's 7 times 1/3 to the first power. 7 times 1/3 is 7/3. Okay, that's so much better. And then my third term is 7 times 1/3 to the 3 minus 1 power. That's 7 times 1/3 squared. And that is 7/9. So my terms are 7, 7/3, 7/9. Notice my denominator is changing. My numerator is staying the same. That's because my ratio says multiply the numerator by 1, which keeps it the same. Multiply the denominator by 3. All right, so now let's find for the function f of n equals n times negative 2 to the n power. Let's see what this sequence looks like. So this is 9 times negative 2 to the first power. That's just 9 times negative 2. F of 2 will be 9 times negative 2 squared. That's 9 times 4, which is 36. And then f of 3, this is 9 times negative 2 cubed, which is 9 times negative 8, which is negative 72. So my sequence is -18, 36, -72. And I want you to notice here that we multiplied by -2 each time. Where do we see it? It's right there. For this one, we multiplied by 1/3 each time. We see it here. For this one, we had 4, -20, 100. So we multiplied by -5, and we see that there. So keep those things in mind as you go through. All right. Now let's look at example 3. Use the pattern to answer the following questions. So in figure 1, I've just got one little copyright symbol. Figure 2, I've got 3 symbols. Figure 3, I've got 9. So we've got 1, 3, and then 9. So it looks like I'm multiplying by 3. And suddenly I'm rethinking using this because that means I have to draw, let's see, we multiplied by 3 to get 3. We multiplied by 3 to get 9. So we'll have to multiply by 3 again. I've got to do 27 of these. Oh my goodness, 27 of these. Oh, Robadeer, what were you thinking? I don't know. So figure 5, how many of these would I need? Well, I've gone from 1 to 3 to 9 to 27. And again, I could say, okay, well, 1 times 3 gives me 3. 3 times 3 gives me 9. 9 times 3 gives me 27. So what's next? 81. So we're going to have 81 of these. Good night. So we fill in the table. We've got 1, 3, 9. I would have been so much better by having a 4 and a 5, but that's okay. Next time. What is my common ratio? My common ratio is 3 because I see that I'm constantly multiplying by 3. So the explicit formula. So because it's up there out of camera view, the explicit formula is a sub n equals a sub 1 times r to the n minus 1. So for our situation, a sub n equals the first term, which is 1, times the ratio, which is 3, to the n minus 1. And I'm sort of, I don't know how I feel about that because this is what the formula looks like, but you know that anytime you multiply by 1, you can drop that number. So it's basically 3 to the n minus 1. The question is, would you be able to find the first term? And so just remember, you can always bring the 1 back out. So the recursive formula, I define the first term. Good grief. And then to find my current term, I will take the ratio times the previous term. So for this situation, my first term is 1. My nth term will be 3 times the previous term. And again, I'm giving you the same formulas that are here on the GMass formula sheet. In my sequence, the recursive formula just says it's r times a sub n minus 1. The explicit formula tells you it's the first term times r to the n minus 1. Okay? And notice we've got our exponential, we've got our interest. We've discussed those before. Above that is your arithmetic, and again, you'll see recursive and explicit. So please keep those things in mind. All right, for this last one, Rusty ran 2 miles Monday, and he wanted to double his distance each day. Good for you, Rusty. So we want to create a sequence that represents the distances he will run from Monday through Friday. So on Monday, he will run 2 miles. So on Tuesday, if we want to double that, he's going to run 4 miles. And when we double that for Wednesday, he'll have to run 8 miles. Good night, Rusty. On Thursday, he runs double of Wednesday. And then on Friday, whoa, he's going to run double of Thursday. So notice here, my first term is 2. My ratio also happens to be 2 because we're multiplying by 2 as we go. But also because you know I'm extra, if I asked you for the domain, you would tell me, well, the domain is term 1, term 2, term 3, term 4, term 5, or day 1, day 2, day 3. Domain is my input. My range is always going to be the sequence. So my range are my output values, my 2, my 4, my 8, my 16, my 32. I had to bring domain and range in because it's so important, okay? So just to recap, we're going to be dealing with geometric sequences where you multiply to get the next term. You multiply by a whole number, you multiply by a fraction, a decimal, whatever the case may be. It's helpful to know the first term and the common ratio so that you can actually write out the functions or the equations. We've got our recursive formula, first term and ratio. Our explicit formula also requires the first term and the ratio. So there's everything you need for a geometric sequence.